The BESSELI function. It returns the modified Bessel function, which is equivalent to the Bessel function evaluated for purely imaginary arguments, and is the syntax, which is BESSELI x, n. X is the value at which to evaluate the function, and n is the order of the Bessel function. Here's the formula, which is I sub n of x equals I raised to the power negative n j sub n of ix. And we'll use these formulas to generate the Taylor series expansion in our Excel spreadsheet and Google Sheets. We begin with the dataset of BESSELI. So BESSELI of the value of x, comma, n. And our value for n is data validation from the list 0, 1, 2. And you can start with 0. Still an error. So refresh. It does not work. Now it's lost. We'll change this. Refresh again. You cannot use dynamic array when it comes to BESSELI. So we'll change this. Lock the reference for B12, the value of n, and we'll start with the first cell, A3. Now it's better. Then we drag this downward. Still not updating, so refresh. Now it's better. If I change this to 1, n equals 1. Okay, refresh. That's better. Now we continue with the Taylor series expansion with summation of a times x to the power n plus 2k, and the value of k is 0 to infinity. Refresh. And the value of a is equal to 1 over, now there are 3 parts. The first part is factorial k. The second part times gamma. That's gamma n plus 2k, n plus k plus 1. So n plus k plus 1. And finally, the third part, 2 raised to the power, the quantity, n plus 2k. So n plus 2k. And enter. Doesn't work. So I need to close the parentheses. That's better. I can change this to 2 and refresh. Now we complete the series sum. So let's try series sum of the x values raised to the power n plus 2k, where n plus 2k starts from n, incremented by 2k, which is 2, and the coefficient will be this range. It does not work. So we go back to locking the reference. This one and this one, P12, and in case of A3, and enter. And we drag this downward and refresh. Now that's better. Change this to 0, n equals 0, and refresh. Now there's an error. Any number raised to the power 0 is 1. So we change this. If error, If error, then 1. This is a problem with the Excel spreadsheet. Any number raised to the power 0 should be 1. And refresh. Go back to 0. Okay, so that's corrected. Now the chart. Insert chart. We cannot use this, I'm sure. We don't want this straight line here because this is the blue and this should be the red, but you have a gray line here. So this chart doesn't work. We'll just insert the chart from here. So insert chart. Now they're here. So the red and the blue. The title, we don't need that. We need a space, turn it off. The legend, turn it off. But the series, you need a trend line, turn it on. The type, polynomial. The order, let's try 10, which is the same as Google Sheets. It does not work. The maximum is only 6. And you show the trend line, the equation. The same thing with the expansion with red. Turn it on. And I want the polynomial. Display the equation, the degree, we're only limited to the 6th order. We calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix. So we have here the components. So this is equal to the x values raised to the power 0 to 6. Any number raised to the power 0 is 1. That's a problem with Google, the spreadsheet, the Excel spreadsheet. So we write there, if this is 0, then 1. Now it's corrected. We continue. We can now use LINEST. Data y and data x. And here, LINEST for the expansion. Data y, data x. So let's look at the polynomial. So coefficient of x to the 0, 1. This is 1. 0.312. Yeah, this is 0.312. 0.9859 is x cubed. 0.6364. 2775, 2755, and this is 0.516 and 0.046. Now we can use the Google Sheets. In the case of Google Sheets, so the same thing is data validation, list of items 0, 1, 2, and save. And we can start from 0. And it's the summation of a times x to the power n plus 2k, where k is 0 to infinity. And the value of a equals array formula 1 over, and there are 3 parts. The first part, factorial k. The second part, times gamma n plus k plus 1, n plus k plus 1. And finally, the third part, 2 raised to the power n plus 2k. So 2 raised to the power of the quantity, n plus 2k. N plus 2k. Enter. Now we can complete the series sum. Array formula. Series sum of the x values raised to the power n plus 2k, where n plus 2k starts from n, incremented by 2. And the coefficient will be this range. And we chart this. So insert chart. And we use scatter chart. Column A as label. That's a feature in Google Sheets, not found in Excel. And use scatter chart. And we can show the trend line. Series, trend line, polynomial. Actually, we can go as far as 10th degree or almost 6 degree because are limited only to 6, so 6 degree. For the label, use the equation. And for the legend, position at the bottom. We don't need a title. Delete it. So here's our trend line and polynomial. We calculate this polynomial regression coefficient using LINEST. To do that, complete the LINEST matrix. Array formula of the x values raised to the power 0 to 6. And we can use LINEST. That is data y and data x. So, going back to the Excel, we use n equals 0. We have these coefficients. In Google Sheets, at n equals 0, we also have the same coefficients. And we don't need to refresh. Just change it and automatically everything updates. Change it to n equals 2, it operates. In the case of Excel, change this to 1, you have to refresh. And it doesn't even follow the instruction. Now it's refreshed. See if the answers are the same. That's 0, 19.81, 0.731, 557. Let's see. This is 0, okay, 0.713, 0.557, so it's the same. Change this to 2. It updates. Change this to 2 for Excel. But you have to refresh. This explains the BESSELI function in the Excel spreadsheet and Google Sheets. You see why mathematicians prefer Google Sheets to Excel.